Hey everyone, so a few days ago I put up a video about how to choose the perfect camshaft. Of course, those of you who've been watching for a while, you know we're just now diving into M8s. We spent a lot of time with twin cam, now it's time for you M8 guys. So in that video I explained what camshaft specification numbers mean. Today, I'm going to compare the three most popular camshafts for M8, show you the numbers, explain what they mean, and we're going to look at some dyno sheets. Small variations in camshaft specifications can make an enormous difference in the characteristics of the cam. Now, one of the things I want to point out in this video, I did not dyno these motorcycles, okay? The numbers I'm going to show you came directly from each manufacturer's website, and I feel that's probably the most unbiased way to report the camshaft numbers. It made the tuning system irrelevant to a very large degree. We have to assume that most manufacturers are going to publicize the best results they were able to obtain by using their particular camshaft and post that on their website to market their product. So let's dive into the numbers and have a look. Okay, so the three cams that we're comparing are the Zippers 468, the S&S 465, and the Fueling 465. Let's start out by looking at the lift numbers. Right off the bat, you'll see the Zippers 468 has an intake and exhaust lift of 470. The S&S 465 has an intake and exhaust lift of 462. But here, with the Fueling 465, you'll see that the intake lift is actually 445 and the exhaust lift is 465. So referencing my previous video, at first glance you would see these lift numbers and you would think the Zippers cam having a little more lift, it's going to garner more horsepower and really more power over the entire RPM range than the other cams. Now the S&S 462 is kind of the mid-range. Fueling with a 445, you would think that that cam would garner much less horsepower. But one thing about the characteristic of lift, sometimes with less lift, you will actually increase torque considerably, okay, because that keeps the port velocity up and things like that. So let's move to the next number, the intake close. So for the Zippers 468, you'll see that the intake close is 16.5, the S&S cam is 14.6, and the Fueling cam, the intake close is 23. Now what that means right off the bat, the cam that has the lowest intake close or the earliest intake close is going to be the camshaft that's going to produce the most torque. That intake valve is closing sooner. It's going to build up much more cylinder pressure, which is going to garner more low-end torque and build that up a bit. Now you'll notice the S&S cam again is the lowest one at 14.6. So that's right off the bat. Again, we would think that that particular camshaft is going to produce the lowest torque value. Then our intake close at 16.5 with the Zippers cam, it's a little more of a mid-range, where the Fueling intake close at 23, that's a very, very late intake close. Okay, so right off the bat, when I see that number, what I see is a 445 intake lift with a 23-degree intake close. What that's going to do is build more of a horsepower number at the top end because we're not making quite as much cylinder pressure. So then let's move on to the duration. So with the Zippers cam, we've got 205. The S&S cam, we've got 197.2. The Fueling cam is at 207. So there again, we're seeing the S&S cam at 197.2. A lower duration is going to garner more low-end torque. The Zippers duration at 205 is a little bit more of a mid-range. And then the Fueling cam is at a 207. Again, that higher duration number tends to move your torque curve higher up in the RPM range. Now things get interesting really when we look at intake centerline. So if you notice the Zippers cam is at 94, the S&S is at 96, and the Fueling is at 99.5. Now the higher the intake centerline number tends to move, again, that power curve later in the RPM range, that torque curve later in the RPM range. So I would think with the Zippers cam at a center line of 94 is moving more torque down lower in the RPM range. But because they have a longer duration and a higher lift, I would expect to see a more balanced power curve and more than likely an increased power curve when compared to the other two camshafts. So let's have a look at the dyno sheets. Now I'll say again, all three of these dyno sheets were provided by the manufacturer directly off of their website. In the upper left hand corner, you'll see stock versus the S&S cam in the upper left corner. Then you'll see Fueling's dyno sheet for that cam. Then you'll see the dyno sheet for the Zippers 468. Now all three of these engines were tuned, or excuse me, the cam was installed on 107s of the same year. By just looking at the shapes of the graph, you can see that they're vastly different camshafts. The two that have the most similar profile would be between your S&S and your Zippers cam. With the Fueling cam, the shape of the curve, the torque curve, does look drastically different. So now let's have a look at what the peak number results were. Incredibly different peak numbers. Okay, but you'll notice when we compared the numbers and the description of each one of the specifications, it follows exactly in line with the results that have been achieved. So you'll notice that the Fueling cam has 105 horsepower, actually the most horsepower out of all three cams. But when we reference back to those specifications, that's exactly what we would expect to see. Example, we've got a much lower lift. We have a much later intake close, we have a much longer duration, and the center line is also, again, the highest number at 99.5. So what we would expect to see, because all of those other characteristics of the camshaft, other than the lift, moves the power curve much higher in the RPM range, we would automatically expect the horsepower number to be higher. And that's one of the ways that you can achieve a higher horsepower number, is by simply moving your peak torque number or your torque curve higher into the RPM range. So they were able to achieve more horsepower because they're making torque later in the RPM range. The difference between the S&S and the Zippers cam, you'll notice the torque values are very similar. So when we go back and look at the numbers, you will see that our intake center line, our duration, and our intake close are very close to each other. So we would expect to see a very similar peak torque value. But then we compare the Zippers to the S&S with a vastly different horsepower number. When we go back to the numbers, it's exactly what we would expect to see. We would see more lift on the Zippers cam, a little bit longer duration, and a little bit later intake close. All of those things are going to spread the torque curve out a little more and garner more horsepower between those two cams. Now we need to discuss the shape of the torque curve and not pay as much attention to the peak values, because that's, in a lot of cases, that's really what matters. The shape of the torque curve and the area under the torque curve. You can see here, again, vastly different. What I've done here is extrapolated all the information from each of their provided dyno sheets and separated that into the major RPM breakpoints. And we can see there are considerable differences between the three, even though the specifications aren't quite as far off. Now, from reading those specifications, we'll notice in green the Zippers values right off the bat are considerably higher until you hit about 3,500 RPM, where they get much closer to each other, and then the spread happens again, where you'll see flat line relatively across the top. The Zippers cam is maintaining almost 10 more foot-pounds of torque above 3,500 RPM than the S&S cam. When we look at the Fueling cam, you'll see how it is more similar to the Zippers cam, again, because of the specifications. So again, let's do a quick review. We notice at 2250 RPM, we're going to make considerably more torque on the Zippers cam than we are the other two cams. The shorter intake, or the mid-range intake close, the much lower intake center line is what is helping us make so much torque at such a low RPM. As we come up in the RPM range, you can see that the Zippers and the S&S cam get very similar to each other. Okay, where your mid-range is coming in, they have a very similar lift, they have a very similar intake close. And then as you go higher in the RPM range, you'll see that the Zippers 468 is maintaining its torque curve longer at almost 10 to 15 more foot-pounds than what the S&S cam is. And of course, a large part of that is due to having the extra lift and also the extra duration. So it's very well balanced. Now when we compare the fueling cam and we're looking at the Zippers cam, for example, you'll see how that torque number gets very similar, almost identical, once you reach 5,000 RPM. And that would be because, one, we do have the lower lift on the fueling, which is garnering a little more low-end power, but the late intake close, the longer duration, and the intake center line being so much different, it's building more power in the upper RPM range, more torque. Now, when we compare the S&S cam, we see that we've got less lift than the Zippers cam. We have that little bit earlier intake close, a little bit shorter duration. We would expect the torque curve to fall off earlier because all of those numbers are favoring the low-end torque side of things. Now, an interesting fact to point out. If you go back to twin cam days, you'll remember that many exhaust manufacturers, if not all exhaust manufacturers, advertised their exhaust systems along with dyno sheets, showing such a dramatic increase in performance. On twin cam, you could see as much as 10 to 15 horse and torque gain by simply bolting on an exhaust system. But as M8s have evolved, you'll notice exhaust manufacturers aren't selling their exhaust along with dyno sheets and claims of power improvement quite as much as they did with twin cam. The simple fact is, M8s are very finicky on exhaust systems, and quite often the stock exhaust system, depending on how it can be modified, can produce as much or more power than some aftermarket exhaust systems as well. That's not always the case and is dependent on the build that you have chosen for your bike. One interesting aspect, the variable between these three camshafts, both Zippers and S&S torque results that you see here are based on the factory head pipe with the catalytic converter still in the factory head pipe and slip-on mufflers. The fueling cam, they use the D&D billet cat. Now, could the D&D billet cat be reducing their power output, reducing their torque input because the reversion is a little worse, the scavenging isn't maybe quite as good as the exhaust system? Is it due to a little bit of extra back pressure because of, let's call it back pressure, a little back pressure because of the catalytic converter? Who knows? It would take some independent testing to figure that part out. But those three aspects of this could very well play a part as to why fueling's numbers are much lower than Zippers and S&S numbers. Of course, there are other variables that come into play. The type of tuning system that they used, which technically should be irrelevant. If you were tuning to the same air-fuel ratio and ignition timing setup, your results should be virtually the same. But because this is the highest number, we can assume that was obtained by the manufacturer. They chose the tuning system that they chose to produce these best results. So we're just going by the best results that they provided. And there are also other variables. Dynos can vary from one to the other as much as 5 and in some cases 10%. Atmospheric conditions, condition of the rest of the engine, things like that will all come into a play. And I hope this helps you understand a little bit more about camshaft numbers and what they mean and how they can affect the power curve. If you didn't see how to pick the perfect camshaft video, I'm going to put a link in the description below, and I'm also going to put a tag to it up here on the side, as well as a link to our playlist with all of our other tech videos for you Harley-Davidson owners. Thanks a lot for watching, guys. Take care of yourselves and each other. Have a good one.